Welcome to Savanna Techie. I'm your host, Rafael Ndwiga. If you're new to the channel, kindly give me your support by hitting the subscribe button and also the bell icon so that you can get notification whenever I upload new content. If you like the video, kindly like and share it with your peers. So in this tutorial, like I promised, we'll be looking at GCC Compiler and its options. So let's get started. So according to the official documentation, the GNU Compiler collection, also known as GCC, includes frontends for C, C++, Objective-C, Fortran, ADA, Go, D, and others. And it was originally written as the compiler for the GNU operating system. The GNU system was developed by 100% free software, so with GCC, so you don't have to buy GCC for you to use it. Now, the objective of this tutorial is we are going to be looking at the following compiler options. There are other options out there, but you'll find yourself at times using these ones more. So we'll be using the O option, the wall, the W extra, the pedantic, the E, C, L, and so on. So we'll be actually be going through this list, and as we go through the list, what we will be doing is that we will be writing a program and then writing a C program and then compiling it using the option given. Okay, so kick us off. Let me launch my terminal. There we go. So let me edit first so it can go through. So in the last tutorial, whereby we're introducing a C programming language, we covered the semantics of a basic C program structure, and we said that for every C program, it has what we call include directives. Okay, let me just go back to the particular slide. Okay, where it is. Yes. So we said we have a preprocessor statement, and the preprocessor statement indicates what code base we want to borrow from C to use in our program, and one of them is the standard input output library. So we include that one using the hash include and then stdio.h, and then we talked about multi-line statement, talked about single line comment, and then talked about the main, and that the main program is where all the execution begin. Also, we saw how to compile code, and we use simple compilation, basically basic compilation, and we say that in computing, a compiler is basically a computer program that translates computer code written in one programming language as the source language into another language, which can also be referred to as the target language. So basically, a compiler is primarily used for programs that translate source code from high-level language to low-level language. Now, apart from that, we also looked at what the compiler does under the hood, and we looked at the 4 components that do specific tasks. We looked at the preprocessor, compiler, assembler, and linker. Now, when it comes to GCC compiler options, they will enable us to be able to compile our source code to either of these stages. So if you want to see the result of a preprocessor, there's a switch for that. For a compiler, there's a switch for that. For an assembler, there's a switch for that. And for a linker, this is a switch for that. And if you want to generate all the intermediate files as GCC compiles, then this is a switch for that. And if you are what should I say, adventurous and you like to see all the commands that the compiler is executing as it's processing the code, as it's compiling the code, there's also a switch for that. So basically there is almost a switch for anything you can think of while you're compiling your code. Okay, so let's get moving on. So we say that for basic compilation, the command to use is gcc and then the file name. And if you want to specify the output executable name, then to achieve that we use the O switch, okay, or the O option. So let's do the first basic compilation, and for that my terminal, there it is. So I'm going to create a directory and call it basic compilation, and then I will cd to it. Okay, so let's create the first C program, and then we compile it using basic compilation. So we will do just directly and say touch, and then say basic compilation, and we said source codes for C have to end with extension .c. So we'll say .c, and then I'll use the VI editor to write the code. So I'll hit enter, then I to go in insertion mode, and the first line we include is the preprocessor directive. So we will do an include. Okay, so oh boy, include, and then the command is turn stdio.h, and then some space. So then we write the main method. So before we write the main method, we'll say we write a comment. Okay, and this comment we will say that it is you, basically the comment that we write on top of the main function. Okay, we will say what the purpose of this particular code. So this just prints out hello world. So okay, and then I will end the comments in that way. So you can see we have a convention for writing comments. So that's a convention, and then we say that the main statement returns data type of type int. Okay, so now we'll say that it returns an int. The main function accepts void, that is accepts nothing. Then hit enter, open the curly braces, enter, and then one tab, and say it uses the command print printf. Okay, hello world, and then I will end this in with a new line. Okay, so I will have it that way, close it, and then end that statement with a semicolon, hit enter, and then return space 0. So what space 0 mean? What return 0? Return 0 basically means success. So if the program reaches through this return value, it means that it executed successfully. So basically that's what the return 0 implies. So full colon, then X to save. So we can see that the code there. If we do cut basic compilation, we have our code together with the comment. So now to compile it, basic compilation, we just say GCC and then basic compilation, hit enter, and you can see at default we don't give an output file. What the GCC compiler does, the output will be the output file, or the executable file will be an a.out. Okay, and this a.out is light green in color, basically to indicate that it has an executable bit. To know that, you can do ls, then la, and you can see the executable bit on that particular file. Now to run it, you use the command ./a.out, and you can see the hello world introduced a bug there. Let me just fix it quickly. Rather than / we should have done \. So that way, save and exit, compile it again, and run it. Correct. So that one we are done. Now when we want now to specify the output, we want to specify the name of the executable file, we use the O option. So if we want to use to give a name, then the option to use is -o. Okay, so now to get there, what we'll do is for the same one, we will issue the command gcc, okay, and then the source file, basic compilation -o, and then I can give it any name. So any name. So I'll just say Savanna _Techie, hit enter. If I do ls, you will see that particular file. Now the output having been named. So I can then run it, just issue that, and the same results is given. So I can run that again, and let me just remove the files I don't want. Yes, remove that file. And no, don't remove that. Yes, remove that. I do ls, and then issue the command again, gcc source file -o Savanna Techie, hit enter. The source file is there, run it there, and there we go. Now onto the next option, into the next GCC option. So the next GCC option is where we want to enable all warnings. So we want that if GCC encounters anything that encounters anything, we want it to issue warnings. And to do that, we use the switch -W wall. So warn all. So warn all. So W basically means warn and then all. So for that, the result will basically be the same. So in this case, I will do ls, and then I'll just recompile again. So say gcc basic the source code, and then okay, so say gcc then hyphen wall, okay, then the source file, and say output. I will say this one's for all warnings. Hit enter, and then you can see it compiled without any warning. So we are good. If you run it, all is fine. Now if we want to enable extra warnings, okay, extra warnings, then we use the switch hyphen w extra. So basically means hyphen give us extra warnings if at all they're there. So, and we can and the thing about switches is that you can chain them, or you can combine multiple options or multiple switches. So in this case, we'll compile still the same program and say gcc hyphen w extra, okay, and then I can combine the wall, but let me not combine it at this particular time, and just say Savanna Techie .c. Oh, sorry, basic compilation, and then output should be say extra warnings. Hit enter, ls. There are no other warning set. And then if I run it, as it gives us the same it gives us a result, and we can combine like I mentioned earlier. So I can come here and combine and say wall. So give all warning, extra, everything. Give me all the warnings you can give, and then hit enter. And let me just repeat that one and say extra all warnings. I do ls, so there are no extra all warnings set, so extra all warnings, so we are good. Now when we want to see whether, or when we want the compiler to catch any code that violates a strict IOC standard, then the switch for that is pedantic, hyphen pedantic. Okay, so what it does is that that particular switch tells the compiler to reject any code that is not compliant. Okay, so for this I'll just go back, and then I'll just get another directory and say pedantic warnings, cd pedantic warnings. I will create another C program. So the basics of always when you're working through of creating different C programs, especially for a new C programmer, is so that you can get used to the motions or to the nuisance of writing writing C programs. So I will say touch and call this file pedantic warnings.c. okay, so all C source code ends with .c. All C header files end with a .h. So a .h extension for header.c, extension for source code. So say vi, then pedantic, and then I go insertion mode, and then include, okay, stdio.h, okay, then comment. So then say that this program requests user input, okay, then gives the sum of input back. All right, so I have my comment there, and then we say that a main statement returns an int value. So, and main takes void as a parameter. Void means nothing, so it doesn't take any parameter. Then open the curly braces. So you can see where the position of my curly braces. So when you're writing your code, you should have it there. Hit enter, then a single tab, and I will define a type int and say value 1. Excuse me. Value 1. Then we have value 2. Okay, and then we have sum total. All your C statements should end with a semicolon, and then I will request for user input. So for that, we'll say to request for then we request for user input, and before request for user, we request for user input, and then take the inputs and then print the inputs back to the user. Okay, so for that we'll use the command. So we'll use the command printf. Okay, so where did it go? Yes, so we use the command okay, just a moment. All right, append tab printf, then kindly put 2 variables to get sum of. Okay, then full colon that way, and then end it with a semicolon. Then to get the values of to get now the those particular values that will be entered on the standard input. So we use scanf, and then use the formatted input. So we'll use ampersand, yeah, so ampersand D, then also D. Okay, then we'll close that, and then not ampersand, sorry, percentage, and then we refer to this these variables here. So we refer to this particular variables reference. So use an ampersand. There we have value 1, and then another ampersand, and say value 2. Okay, close the bracket, end the semicolon, hit enter, and then we say sum total equals to value 1, plus value 2, and with a semicolon, and then we print out now the results to the user. So we use printf, and then we say that the sum of the given values, okay, and then percentage sign d and percentage sign d is equal to, and then d basically means we will be passing in an integer value of base 10, and then now we once we close in the quotation mark indicating the end of that particular string with formatted string, so we'll say value 1 and then value 2, and finally sum total. Close the bracket, then end some colon, okay, and then finally we say return space 0. So return an integer of the value of 0 to indicate success. So then we'll save and exit. Okay, so now we are working with pedantic warning. So to compile this, we'll use GCC. I want you to give me also warnings and also extra warnings. Okay, and then what I wanted to do, we are working with the pedantic switch, so we'll also now include it. So hyphen pedantic, and then the source file is pedantic, and then the output file, we say the file say we are strict. Hit enter. Then we can see the file has been generated. There are no warnings, so meaning that we are good. So it asks for two variables. Give it 76. Give it another value, and it prints the sum total. So just to reiterate, previously we said that with scanf, it only terminates. It terminates with white spaces and end of file. So that's how we do about. That's how we go about adding a pedantic switch to GCC compiler. Now, next, we want to produce only the preprocessor output through the E option. Okay, so we want to produce the preprocessor output through the E option. So we talked about the various stages of compiler, and the very first stage is preprocessor. So now to do that, or to get a particular code produced by a preprocessor, then we will use the same code for like we use for pedantic. So ls here, let me just clear first. Okay, so let me remove we are strict. We are left with our source code. So we want to get the preprocessor output. So for that we say GCC, okay, and then hyphen capital E, and then the source file, and then put the source file. So let's also do this particular option. We hit enter, and you can see the machine code having been generated. Okay, so this is the preprocessor code. This is the preprocessor code. So you can see that it prints the preprocessor code on the standard output. Okay, now if we wanted to have this output, and say if we gave it even the if we did ls, you can see there no new file generated. Okay, and also if you give the option, say preprocessor output, okay, and hit it and hit enter, you can, and we did a cut of this preprocessor output, you'll see that content there. Now the other way we can go about attaching this particular output to a file. We could use the redirector. So a single redirector, and then say have this file in, say, using redirect it ls, and you can see if you do cut, let's just use using redirect, you can be able to see the code generated by the preprocessor. All right, now on to the next preprocessor directive. So if you want now to only produce compiled code, you use the -c option. Okay, so when you use -c option, GCC will produce a file with a .o extension, okay, which contains the machine level code. So machine level code. So now the difference between the preprocessor and the compiler is the preprocessor removes it removes comments. Let me just show you what it removes. Where it is. Here it is. So you can see the preprocessor removes all the comments. It includes all header files within the source code, replaces macros with source code, and generates intermediate file. So all this content that we were seeing generated by the preprocessor is basically it's basically an inclusion of the standard input library that we included in the preprocessor statement and our particular code. So now to produce the compile code, the machine code, we use the C option. So we'll go right ahead and compile our file using it. So let me do ls here, and let me remove the interactive mode. Remove that. No, this one, yes. Okay, so we are left with that one. So GCC, and we want the compile code, so option C, and then we want we put the source file, which happens to pedantic. Hit enter. We do ls. We can see just a moment. Okay, so let's do a cut a.out. Okay, just a moment. Let's remove a.out, then compile it again. Yes, so the option there is small c, not capital C. Sorry for that. So to get the compile code, use the small c. Now, there are cases whereby you'll want to link a shared library with the source code. Now, to link a shared library with the source code, we use the option -l. Okay, and for example, if let's say we wanted to compile this code and also link it with the math library, then we will use the -lm. Okay, so the compilation will just be similar. So we'll just say gcc. So we'll say gcc, and then we'll say we get the source file. Okay, and then the output fno, we say we want with the link with math, and then fnlm, hit enter, and the compilation is complete. So we can run this, and as you can see, it runs successfully. So there are a lot of libraries that you can be able to compile your source code against. So you can be able to include them in the preprocessor and have them included while the GCC is compiling, or you can manually link a shared library through using the L option. Okay, then earlier on we say that it's also possible to get all the intermediate files. So you don't have to go through the hassle of using single switches to do certain tasks. So to get all the intermediate results. So to get all the intermediate results using a single switch, then what we use the save temps option. Okay, so we'll use the save temp option. So we can do that, and what we will do is we'll do an ls here, and then I will remove the rest of the files with the exception of the source file. Okay, and then compile it gcc with that particular switch save temps. Okay, and then include our source file. There you go, hit enter, and do ls. You can see that it has generated all the intermediate code, and apart from that, it also generates the final executable. So if I do if I run that code, that executable, you can be able to see that our code is running. Okay, so if I used to do say I want to do less and get this interpreted the preprocessed code, so pedantic.i, and you can see the preprocessed code. Now if I wanted to see the compiled code, so I'll go with the .i. So it tells you that may be a binary file. See it, and you can see the binary file itself. Now there's another option of using the switch -f pick A pick basically means position independent code, and when this option is enabled, when this option is enabled, GCC produces a shared library that can get loaded as an address instead of some fixed address. So in short, the fpick option GCC enables the address of the shared library to be relative, so that the executable is independent of the position of libraries. This enables one to share built libraries which has independence on other shared libraries. So, and this is how you go. This is how you go about producing that. So let me ls. So what I will do is that I will go back and then mkdir get a directory and say, call it shared library, shared lib. And then what I'll do, I want to copy cp pedantic. I want to copy the pedantic source file and then put it in the shared library, and then I'll go to the shared library and have that file there. So sorry. So what I will do now, since we have now the source code that we wrote earlier, I can compile it using the fpick option. So I'll do gcc and then we want the compile code, the code from the compiler. We want to enable the warnings, and also fpick and then the source code. Okay, so what it will do is that it will produce it will produce this particular file. Okay, then the next thing that we'll do now is to generate now the shared library. So it has an extra step, so we do gcc then shared and then out, and then now we'll have our source file, our library file being pedantic.so, and then view. Oh, just a moment. No such file or directive. Oh, sorry. So you have to give the file, so fno, or to indicate that to indicate which particular file we are generating a shared library from. So that's how you go about creating a shared library using the fpick option. Now now the other option we look at is the Fmv option. Okay, so the Fmv option is the what it does. It does the GCC to provide verbose information, detailed information on all the steps it takes while compiling the source code. So what we'll do is that we remove this file that we generated here, fni, no, yes. So we'll compile it with option v, so gcc v, and then our source file. Sorry, this is small v. And as you can see, the -v, it has compiled the source code while giving us the commands that it was running as it was doing so. So if you run the output, then you can see that our program is running as expected. So this is a small v. Okay, then we have in our video said that the most portable version, or the most portable standard, the C standard, is the ANSI C standard, also called the C89 standard, or the GNU 89. So the C89 standard. Now, to tell the compiler that you want to compile the code using the ANSI the C89 standard, or the ANSI C standard, we use the option -ANSI, or the option std GNU 89. Okay, so what we're going to do, we clear first of all ls, then remove that file and compile it, gcc all warnings, and then say std GNU 89, and then give our source code there, and then want the output to be ANSI compilation. Okay, if you do that, it compiles, since we have not violated the ANSI standard. So let's add a violation. So let's remove the compiled file, go back and edit our source code, okay, or our source file. And what I want to do, I want to put I won't put these comments that are used in C++. So just comment, okay. And if we're now to recompile the source code again, GNU 89, it compiles. That's interesting. So let's try with ANSI. Yes. So you can see this switch doesn't give us any warning, but the ANSI option does. And what it does, what it tells us is, it tells us that in line 10, C++ style comments are not allowed in ISO C90. Okay, and it also tells us that this will be reported only once per input file. So if you want to have that particular strictness, then can use now the ANSI switch to give you the result that you want. Okay, so in your case, using the the switch std GNU89, it might complain, but in my case it hasn't. So in cases whereby you just want to be sure, you can change them. So let's do this. Let's do let's remove the ANSI compilation, and I will chain them std then GNU 89, and you can see the other particular option has overridden. That switch has overridden the warnings we could have been given. So depending on the switch and dependent on the compiler, the version, so you will get an expected output. Now the other option is, we say you want to convert errors, convert warnings into errors with W error option. Okay, so what we'll do, so close now. Let's remove that particular file and see compilation, and say that we want to convert all warnings into errors. Okay, so we'll compile. For that we use the switch W error. Okay, and let's try something. Let's try compiling the same with W error, and let's give std GNU 89 and see what happens. So no errors generated. Okay, so the W error, what does it turns all warnings to error messages. Now the last thing that we look at is the add switch option. Okay, and what the add switch option does is that it allows you to put all your switches or all the option into a file, and then feed them to GCC. So all through what we have been doing is that on compiling we have been putting the file. We have been putting the options on terminal. Okay, like this. So now what we want to do, we want to define the options in a file, and then include those and then refer to those option using the add option. So to do that, let's get a file. So let's call that file option file. Okay, then vi option file, and we say the first option we want it to be verbose. So we say we want it to be verbose. Okay, so fnv. Okay, and then at the same time we want GCC to save all the temporal compilation. So each stage we want it to give us an output. Okay, so for that we say save temps and then we want to enable all errors. Okay, so let's say those are enough options for us to work with. So now we have that. Let's remove the ANSI compilation so that we're only left with the option file and the source file. So now to compile, we'll use GCC. Okay, so we'll say GCC and then our source file. So our source file is pedantic, and then we'll say the output want it to be we'll say with file. Okay, and then now to add the other options, compiler options, use an @ sign, and then we type in the file name and hit enter, and you can see that indeed GCC did read the option file due to the verbosity of the output. Okay, and if you did ls, we'll see all the intermediate files having been created, and we have on our executable, and when you do with file, then you can see that our file, our source code has compiled successfully. Now we have had a look at GCC compiler options, and so far we have been compiling and running our code in line. By in line, I mean that we have actually been typing the compiler options and they run. What about the case whereby you want to have a script that compiles all your code? Okay, and basically what you just want to is just run that script. Once you have built your C program, you just run that bash script, and it gives you same output as you have had, same output as you will have had by actually compiling that particular code manually. So how would you go about that? So to go about that, it combines the concept of bash of Linux shell. Okay, and you can be able to combine concepts such as variables, filters, since you may want that once your program compiles, you want also your bash script to run it, and once bash script runs the code, you may want to say process the output using a bash script. So how do you go about that? So to get to that point, we will look at the shell environment, and then we will write a script that will be able to do that compilation for you.